Hey y'all, we're going to go over the notes on magnetism in this video. So in magnetism, we've got a bar magnet, which is just a simple magnet. It's going to attract or repel another bar magnet depending on which ends of the magnet are brought together. And I'm pretty sure you already know that information, right? The two ends of the magnets are going to be labeled north and south, and they figure out which end is north and south based on like which way it's going to point towards, like the North Pole of Earth, right? So unlike poles attract, which are going to pull towards each other, and then like poles repel, which are going to push you away from each other. Again, that's probably something you already knew, right? With magnetic fields are a vector force that surrounds any magnetic material. So like how you like can hold magnets together, and like as you bring them close together, you start to feel it, like you're in that magnetic field, right? It's also going to contain an energy just like an electric field would. And the greater the energy in that magnetic field, the more intense the field's going to be. Kind of think of like a really strong magnet versus a weak magnet, right? Magnetic fields can be caused by currents or by the movement of electrical charges as well. It doesn't have to just be like a bar magnet. And then the direction of the magnetic field at a given location is going to be defined as the direction a compass would point if it was placed at that location, right? And we're going to draw them electric field lines pointing towards the south end of a magnet. So like with this bar magnet here, it's going to point towards south, right? Then we have magnetic domains. The magnetic field of any magnetic material is broken up into regions which the field points in different directions. So like we have this random chunk of material, and we've got these magnetic domains in it, and the arrows are showing like which way like their north is, right? A region within that magnetic material where the electrons are aligned in the same direction is called a magnetic domain. So each of these sections of this material are magnetic domains, and they're all pointing randomly different ways or what they're thinking north is, right? You can create a temporary magnet by rubbing like a nail, for instance, it's not normally magnetic, or a paper clip with a magnet. And what it's doing is you're basically aligning all those magnetic domains together, and it only lasts for a moment, but you're temporarily creating a magnet when it does this. Right? An electromagnet is a magnet made from a current-bearing coil of wire, and it's wrapped around an iron or steel core normally. Properties of electromagnets are that they are temporary magnets. They're not permanent. Their strength can be increased with more coils, so add more coils, get a stronger one. Their properties can be changed by changing the current, so more current, less current will change things. And obviously they can be turned on and off. So you can build a very simple one out of a nail, some wire, and a battery source by very similar looking to this diagram. And if you disconnect the battery, then your nail is no longer magnetic. Right? Examples of where these are used are in speakers and headphones, junkyards like these pictures here, and also in some gates that you may like put up a key card to. It may turn off an electric magnet that's like keeping the gate locked. Right? Not to say they're all like that, but some are. Right? An electric motor is a device which changes electrical energy into mechanical energy. So a basic electric motor will have a power supply, a permanent magnet, and electromagnet that can rotate in it. It'll look like this. Don't worry about knowing the details of this diagram though. But a fan that you may have in your house or your room is an electric motor in it. So it's going to take that electricity and make it cause something to move around. Then on the opposite of that, we have a generator, which is when you move a loop of wire through a magnetic field and it produces an electric current. And this is called electromagnetic induction. A generator is used to convert mechanical energy into electrical energy by electromagnetic induction. So we have like a basic diagram here. And power plants do this. Depending on the type of power plant, depends on the source of where they get that mechanical energy from. And then that is going to cause something to spin through that magnetic field, creating an electromagnetic induction, and that creates electricity. Right? We're not going to get into the super details of how that works, but just know the basics and the definitions for now. Right? But that is it for the magnet notes. Let me know if you need any help.